So welcome you all. This presentation is purely for the students prepared for GATE under AICTE PRERANA scheme. So this class deals about the power system load characteristics. I am Dr. Muthukumar from Erode Sengunthar Engineering College, Tamil Nadu. So we know that the load is a seldom constant in power system. So it has a different characteristics. So this is a simple load curve that we can usually see in our all power system subjects. So the load curve showing the variation of load on the power station with respect to time is known as the load curve. So we cannot predict what is the load which is going to be connected with the different time in with a generating station. So generating station are known about the load characteristics. So with the help of the different information we received in the stations, we can calculate the values and the characteristics of the loads. So this is a sample load curve. So we can see. So what is the difference between load curve and load duration curve? So load curve is simply presenting the relation between the megawatt power consumed by the consumer with respect to time. If you are rearranging the elements in the load curve, you will get the load duration curve. So the right side you can see that it is an example of load curve. It gives what is the load consumed with respect to time. In load duration curve, the load elements in the load curves are arranged in the descending order. The area under both the curves are equal, that you can see. So we will see the different problems dealt in the load characteristics. So the first problem, the maximum demand at the power station is 100 megawatt. If the annual load factor is 40%, calculate the total energy generated in a year. So we know that what is load factor. So from that we can calculate the total energy generated in a year. So the total energy generated in a year can be calculated by multiplying the maximum demand and the load factor. And since they are asking the total energy generated in a year, we have to multiply the hours involved in the year. So how many hours in a year? It is 365 into 24, 8760. So it is a very simple problem since the informations are available directly in the problem itself. The maximum demand of the power station is 100 megawatt. The annual load factor is 40%. Then what is the energy generated in a year? So we can multiply the maximum demand with the load factor, which includes also we can include the hours involved in a year. So totally 3504 in 10 power 5 kilowatt hour. This is a very basic problem. Second problem, a generating station has connected load of 43 megawatt and a maximum demand of 20 megawatt. The unit generated being 61.5 in 10 power 6 per annum. Calculate the demand factor and load factor. This is a second problem. So this is also we can easily apply the values in the formula and we can get the values. So demand factor is nothing but maximum demand by connected load. So what is the maximum demand? Given in the problem 20 megawatt. Connected load is 43. So the demand factor is 20 by 43, 0.465. Then we can calculate what is the average demand. So average demand is number of units generated per annum divided by number of hours involved in a year. So both are available in the problem. So it is a unit generated per annum is 61.5 in 10 power 6 and hours involved in a year is 8760. So the average demand is 7020 kilowatt. Next, what is load factor? Load factor is the average demand by maximum demand. So already average demand already we can calculate. So average, sometimes it is referred as average load. Sometimes it is as average demand. So average demand by maximum demand 7020 kilowatt divided by 20 into 10 power 3. So the problem they mentioned maximum demand in megawatt. So the average demand what we calculate is in kilowatt. So the numerator and denominator should be represented with the same unit. So we have to convert the megawatt into kilowatt. We have to represent like that. So both numerator and denominator are represented in kilowatt. So the answer for the load factor is 0.351. The percentage load factor is 35.1%. Next problem number 3. A 100 megawatt power station delivers 100 megawatt for 2 hours. So the station capacity is 100 megawatt. So it delivers 100 megawatt for 2 hours and 50 megawatt for 6 hours, and it is shut down for the rest of each day. So per day we know that it is 24 hours involved. So in that 2 hours the station delivers 100 megawatt and 6 hours it delivers 50 megawatt. It is also shut down for a maintenance for 45 days each year. Calculates the annual load factor. So in a year the generating station is shut down for 45 days in a year. So the total energy supplied by each working day we have to calculate. What is our question asked is calculate its annual load factor. So annual load factor is nothing but average load by maximum demand. So we have to calculate for a year. So we have to check how many days it is working and how much power it is generated. So energy supplied for each working day. So for each working day how much power the generating station delivered, that we have to calculate. So 100 into 2 plus 50 into 6. So 100 into 2, it means 2 hours it is delivering 100 megawatt and for 6 hours it is delivering 50. So it totally per day it is delivering 500 megawatt hour. So how many hours the station is working in a year? Total days in a year is 365. 45 days it is shut down. So about 320 days it is working. So the energy supplied per year is 500 megawatt hour into 320 days. So totally 160,000 megawatt hour. So annual load factor, the formula is the megawatt hour supplied per annum divided by maximum demand in megawatt and working hours in a year. So already I told you that whenever you are applying for a load factor and substituting the values in the load factor, the numerator and denominator should be represented in the same unit. So the average load is taken in megawatt and the demand also is taken in megawatt. So no problem. So the megawatt hour supplied per annum is 160,000 divided by 100 into number of hours 320 into 24. So 320 days in a year and 24 hours into 100. So the annual load factor in percentage is 20.8. Next problem. A generating station has a maximum demand of 25 megawatt, a load factor of 60%, plant capacity factor of 50%, and plant use factor of 72%. So these are all the information, and from that we can calculate, find the reserve capacity of the plant, the daily energy produced, maximum energy that could be produced daily if the plant while running as per schedule were fully loaded. So with this information we have to calculate. So load factor is generally we know that average demand by maximum demand. So what is the average demand? It is we have to find out. So average demand is from the load factor and maximum demand we can calculate the average demand. So load factor in the problem it is given as 0.6 and the maximum demand is 25. So from that we can calculate the average demand. So average demand is equal to 25 into 0.6, 15 megawatt. Plant capacity factor is equal to average demand by plant capacity. So they ask what is plant capacity. So the plant capacity can be calculated with the help of the average demand and the plant capacity factor. It is 15 by 0.5, 30 megawatt. The reserve capacity of the plant is, so plant capacity is 30, we know that, and maximum demand is given in the problem itself, it is 25. So the reserve capacity of the plant is 5 megawatt. And the daily energy produced produced. So average demand into 24 for 24 hours. The average demand we already calculated. So 15 into 24, 360 megawatt hour. So what is the maximum energy that could be produced by the plant? So the plant effectively, how much power that it could be produced in a day. So that can be calculated. The average actual energy produced in a day divided by plant use factor. So the daily energy produced we just now calculated. It is 360 megawatt. 360 megawatt. So from that we can find out the maximum energy that could be produced with the help of plant use factor. So 360 divided by 0.72, it is 500 megawatt hour per day. Next very important problem. A diesel station supplies the following loads to various consumers. Industrial consumer about 1500 kilowatt, commercial establishment 750 kilowatt, domestic power 100 kilowatt, domestic light 450 kilowatt. If the maximum demand on the station is 2500 kilowatt and the number of kilowatt hour generated per year is 45 in 10 power 5, determine the diversity factor and the annual load factor. Diversity factor and the annual load. So different loads are represented and maximum demand is given in the problem. And the number of units generated per year is also given. So from that we have to find out the diversity factor and the annual load factor. So diversity factor is nothing but the sum of individual maximum demands of the loads divided by the maximum demand of the station. So the sum of individual maximum demand is nothing but, so different loads are given, 1500, 750, 100 and 450. So these are all the different loads and their individual maximum demands are summed up to find out the sum of individual maximum demands. So 1500 plus 750 plus 100 plus 450 and the maximum demand of the station is 2500. So it will give result as 1.12. Diversity factor always more than 1. Average demand is the number of units generated per year or per annum divided by number of hours involved. So the problem itself, it is given as 45 in 10 power 5 and number of hours in a year is 8760. So the average demand is 513.7 kilowatt. So what is the load factor? Average load by maximum demand. Just now we have calculated the average demand. 513.7 divided by 2500. So 2500. So both the numerator and denominator are represented in kilowatt. The answer is 0.205. The load factor in percentage is 20.5%. Next, another important. The daily demands of the three consumers are given below. So it is somewhat difficult or different problem, and so for the different time, what is the power consumed by different consumers. So there are three consumers. So the different times are presented in the problem, and the different times how the consumers, how much they have consumed individually, that is also represented. So from that we are asked to plot the load curve and find the maximum demand of the individual consumer, load factor of the individual consumer, and diversity factor, load factor of the station. So from this information we can find out from 12 midnight to 8 am the consumer 1 is not connected with any load and consumer 3 also not connected. From 8 am to 2 pm the consumer 2 also not used any power, and 4 pm to 10 pm the consumer 2 and consumer 3 not connected with any load, and 10 pm to midnight 12 mid there is no power consumed by the consumer 1. So with this information we have to start the problem. So initially we have to draw the load curve for the given information. So put together with the information by all the three consumers, we have to draw the we have to collect the load elements and we have to plot the load curve. So from the information we can understand from 2 pm to 4 pm the total energy consumed by the station is 2400 watts. So it may be the maximum demand of the station. So maximum demand of the individual maximum demand of the consumer 1 is 800, maximum demand of the consumer 2 is 1000, and maximum demand of the consumer 3 is 1200. So from where it is calculated? So from this chart we can understand. So against consumer 1, which is the maximum power, so they have consumed from 4 pm to 10 pm, they have consumed 800 watts, and consumer 2 from 2 pm to 4 pm they have consumed 1000 watts, and consumer 3 consumed this 1200 watts. This is the maximum power consumed by the consumer 3 at 2 pm to 4 pm. So these are all these values are the maximum demand for the different consumers. So for maximum demand of the consumer 1 is 800 watt, and maximum demand consumer 2 is 1000 watts, maximum demand of the consumer 3 is 1200 watts. So load factor we can calculate for the consumer 1. So load factor is average load by maximum demand. So energy consumed per day divided by maximum demand into hours in a day. So from the details given in the problem, we can calculate the energy consumed per day. So for 6 hours they have consumed 600 megawatt, and 2 hours they have consumed 200 megawatts, and 6 hours they have consumed 800 megawatts. The total divided by maximum demand of the consumer 1 is 800 into number of hours in a day is 24. So it represents 45.8% load factor in percentage. Similarly, we can calculate what is the load factor for the consumer 2. So the consumer 2 consumes 200 megawatt for 8 hours and 1000 megawatt for the 2 hours, and 200 watts for the 2 hours. I am sorry, it is represented in watts, not in megawatts. And mistakenly I presented. Sorry. Load factor for the consumer 2 is 200 watts in for 8 hours, and 1000 for 2 hours, and 200 for 2 hours. So it represents 16.7%. So similarly we can calculate the load factor for the consumer 3. So the consumer 3 for 6 hours they have consumed 200 watts, and 1200 watts for 2 hours, and 200 watts for 2 hours. Divided by total maximum demand of the consumer 3 into multiplied by number of hours in a day, 24. So the load factor, percentage load factor of the consumer 3 is 13.8%. And we can calculate the fire diversity factor for this station. So individual maximum demands are 2400 divided by the individual maximum demands are 800 plus 1000 plus 1200. It is about, we can calculate, this is about 3000 divided by 2400. This is the maximum demand of the station. So already I told you that this 2400 is from 2 pm to 4 pm. So put together all the consumers consuming more power during that particular period. So the maximum demand of the station is rises about 2400 watts. The station load factor is the total energy consumed per day divided by maximum demand into 24. So 8800 plus 4000 plus 4000 divided by 2400 into 24 into multiplied by 100. So 29.1%. It is a station load factor. Next problem. The annual load duration curve of a certain power station can be considered as a straight line from 20 megawatt to 4 megawatt. To meet this load, 3 turbine generator units, 2 rated at 10 megawatt each and 1 rated at 5 megawatt are installed. Determine installed capacity, plant factor, unit generated per annum, load factor and utilization factor. So with this information we can find out hours in a year is 8760 and the load is falling between it is the maximum value generated by consumed by the load is 20,000 kilowatt and it is 4,000, minimum is 4,000 kilowatt. So it lies between 4,000 to 20,000. So energy generated so per year. So this curves, this representation is like a triangle shape. So under the load duration curve, so it is 1 by 2 into 20 plus 4 into 8760. So 20 plus 4 BH, normally that formula half into BH, that we can calculate the energy generated. So we can understand with this load characteristics of a particular generating station, we can calculate the energy generated. So the load curve, curve is represented like a triangle. So the formula for that, we can take it as a area under load duration curve. So area under load duration curve is half into BH. So we can multiply and we will get the energy generated. So the average demand is the energy generated per number of hours involved in a year. So 105.12 into 10 power 3 megawatt hour divided by 8760. It is about 12 megawatt. And the installed capacity. So there are they told it is about 3. 10 plus 10 plus 5. 2 10 megawatt and 1 5 megawatt. So totally 25 megawatt. So the average demand is 1 by 2 into 20 plus 4. So it is about 12. The plant factor is average demand by plant capacity. Average demand is 12 and the plant capacity at the installed capacity is 25. The plant factor is 0.48. In percentage 48%. So unit generated per annum is, this is similar to that previous one. So already we have seen that one. 1 by 2, 4000 plus 20,000 into 8760. 105.12 into 10 power 6 kilowatt hour. And from that we'll find out the load factor. So average load is 12,000 and the maximum demand is 20,000. So we'll get 0.6 and the load factor in percentage is 60. Utilization factor is maximum demand divided by plant capacity. So 20,000 divided by 25,000 is equal to 0.8 and percentage of utilization factor is 80%. Another important problem, suppose the operation schedule is given like this. From midnight to 7 a.m. only one number of unit is put in operation. 7 a.m. to 12 noon. And this type of condition also given to identify the different load elements and the characteristics of the particular load which is connected with the generating station. So from this different 3 units are there. So when the units are it is put in operation and when they are not in operation. So like that they may give the schedule. So it is for a simple understanding purpose it is given. So another problem, a generating station is to supply 4 regions of load whose peak loads are 10 megawatt, 5 megawatt, 8 megawatt and 7 megawatt. The diversity factor of the station is 1.5. The diversity factor is given. What is diversity factor? The diversity factor is sum of individual maximum demand divided by maximum demand. And the average annual load factor is 60%. Calculate the maximum demand on the station, annual energy supplied by the station, and we are asked to suggest the installed capacity and the number of units. So maximum demand on the station is sum of maximum demands of the region divided by diversity factor. So 10 plus 5 plus 8 plus 7 divided by 1.5, 20 megawatt. So it is given in the problem itself. So from that we can find out the units generated per annum. So unit generated per annum is a load. From the formula of load factor we can find out this one. So maximum demand multiplied by load factor into hours in a year. So the maximum demand is 20 into 10 power 3. Load factor is 0.6. Number of hours in a year 8760 kilowatt hour. So answer is 105.12 in 10 power 6. The installed capacity is 1.2 maximum into maximum demand. It is 24 megawatt. So we can suggest 6 megawatt capacity of generating station. 4 numbers we can suggest. Next, a power station has a maximum demand of 15,000 kilowatt and the annual load factor is 50% and the plant capacity factor is 40%. What is the plant capacity? It is also a similar problem. Energy generated per annum is equal to maximum demand load factor in a number of hours. So maximum demand is 15,000 the load factor is 0.5 and number of hours in a year is 8760, and the final answer energy generated per annum is 65.7 in 10 power 6 kilowatt hour. Next, they asked plant capacity. Plant capacity they asked. So the plant capacity can be calculated with the plant capacity factor. So plant capacity formula we know that it is unit generated per annum divided by plant capacity in hours in a year. So from that we can find out the unknown value of plant capacity. So plant capacity is equal to 65.7 in 10 power 6 divided by the plant capacity factor, which is 0.4 into 8760. So the answer is 18,070 kilowatt. Another is very simple problem. A thermal generating station has installed capacity of 15 megawatt and supplies a daily load of 10 megawatt for 12 hours and 5 megawatt for remaining 12 hours. The plant capacity factor for the station is, so actual energy produced is 10 into 12, 5 into 12, put together it is 180, and the maximum energy that can be produced is 15 into 24, 360. So the plant capacity factor is 0.5. Again, it is a very simple. The load duration curve shown in the system is given in the figure. Determine the load factor of the system. So from this, the load curve. So load curve is represented, it is load duration curve is given since the load elements are represented in descending order. Am I correct? So from that we can find out what is the actual energy consumed. So actual energy, we can see that about first of about 10 hours the energy consumed is 18. So 18 into 10. From 10 to 18, about 8 hours it is consumed 15. So 15 into 8. And from 18 to 24 hours it is consuming 10. So it is deals about 6 hours. It's the last element covers 6 hours. So 6 into 10. So put together we can find out the actual energy generated. So 18 into 10, 15 into 8 plus 10 into 6, 360 megawatt hour. So the average load is equal to 360 divided by 24, 15 megawatt. The maximum demand is 18 megawatt. So from this figure, which one is the maximum? 18. So 18 megawatt. Load factor is equal to average load by maximum demand. 15 by 18 is equal to 0.833. This is the load factor. Next, an industrial consumer has a load pattern of 1000 kilowatt at 0.8 power factor for 8 hours and 15,000 kilowatt at unity power factor for 16 hours. The load factor is. So we can find out whenever the power factor is given, we have to multiply it with the load. Okay, load. The first one is 1000 kilowatt at 0.8. So 1000 into 0.8. The time is 8 hours. And second power consumption is 1500 watt. So 1500 kilowatt into unity power is 1 into 16 hours. So divided by maximum demand. So from this we can find out about 16 hours 1500 kilowatt is consumed. So the 1500 is the maximum demand. So 1500 into 24. So the answer is 0.844. It is very simple. So that's all. So I think the student can understand. So what is the different problems involved in the load characteristics in a power station. Thank you so much.